Hello children, welcome back to Guru Gedara. How are you today? Excited to learn another new mathematics lesson in grade 6? Today for our grade 6 children, we brought you the second lesson for the third term, that is lesson 19, algebraic expressions. Do you remember what we have done in the previous lesson? That is lesson 18, algebraic symbols. Okay, first of all, let's recollect what we have done in the lesson algebraic symbols, because algebraic symbols are the foundation to algebraic expressions. We learned some new words in algebraic symbols. We learned about non-terms. Constant values which are known are called non-terms, and we use numbers to represent non-terms. Then we learned about unknown terms. Constant values which are not known are called as unknown terms. Then we learned about variables. Values that does not stay fixed are called variables. Then we introduced algebraic symbols, that we use algebraic symbols to represent unknowns and variables. Then we discuss more about algebraic symbols, that we can use any simple letter of the English alphabet as an algebraic symbol. Okay, now before talk about algebraic expressions, I would like to do some numerical expressions with you. I know the term numerical expression is new to you, but don't worry. You have done numerical expressions when you are in small grades. What do we need to construct numerical expression? We need numbers. We have 10 digits. We know that we can construct any number in the number line using these numbers. Then we need mathematical operation. We have 4 basic mathematical operations: addition, subtraction, multiplication and division. We have 4 basic mathematical operations: addition, subtraction, multiplication and division. This is addition. We can use this addition symbol for the terms like plus, sum, altogether and all. This is subtraction. We can use this mathematical operation for the terms like subtract, minus, take away and difference. This is multiplication. We can use this multiplication for the terms like multiply, product, times, double, triple and twice. This is division. We can use this mathematical operation for the terms like divide, quotient, each and divide equally. Okay, now using these numbers and mathematical operation, shall we construct some numerical expressions? Here is my first example. Rajitha has 14 rupees. His mother gave him 20 rupees. Amount of money Rajitha has now. Rajitha has 14 rupees. His mother gave him 20 rupees. Then to get the total amount that Rajitha has, we have to add the two numbers. Now this is a numerical expression. Can you see? It has numbers and also a mathematical operation. We can simplify a mathematical operation To get the total amount of money Rajita has now, we have to add 14 and 20. Now this is a numerical expression. It has numbers and also a mathematical operation. We can simplify a numerical expression further. When we add these two, we get 34. Then the amount of money Rajita has now is 34 rupees. Okay, shall we move to another example? Take away 5 by 25. Here you have the word take away. What is the mathematical operation that you can use for take away? It is subtraction. We can write a numerical expression like this: 25 subtract 5. Here you can simplify this numerical expression further. 25 subtract 5 is 20. Let's move to another example. Sanjay had 12 oranges. He divided equally among 3 friends. How many oranges each gets? Now can you see, children, we have divided equally. Then what is the mathematical operation that we can use? We can use division. So I can write a numerical expression for this. Sanjay had 12 oranges and he divided equally among his 3 friends. Now this is a numerical expression. It contains numbers and also mathematical operation. We can simplify this numerical expression further. When we divide 12 by 3, the answer is 4. Then each got 4 oranges. Let's move to another example. Sama saw 5 frogs. Amara saw twice as many as Sama. Number of frogs Amara saw. Now can you see we have the term twice. What should we do when we have twice? Yes, we have to multiply by 2. So to find the number of frogs Amara saw, we have to multiply 5 by 2. This is a numerical expression. It has numbers and also a mathematical operation. We can simplify this numerical expression further. Then we get 5 times 2 is 10. Amara saw 10 frogs. Okay, I hope you got the idea of numerical expression. Now shall we move to algebraic expressions? What do we need to construct algebraic expressions? We need numbers. We have 10 digits and we can make any number in the number line using these 10 digits. Then we need mathematical operations. We have 4 basic mathematical operations: addition, subtraction, multiplication and division. Then we need algebraic symbols too. We can use any simple letter of the English alphabet as an algebraic symbol. There are 26 simple letters. You can use any letter as an algebraic symbol. Now, using these numbers, mathematical operations and algebraic symbols, shall we construct some algebraic expressions? Here in the picture, you have a library. I donated 4 books to the library. Now, I want to find the total number of books in the library after I donating these 4 books. Number of books in the library is an unknown. Therefore, we have to use an algebraic symbol for that. Here I used n. Then the number of books donated, it is 4. Then what should we do to find the number of books in the library now? We had n books in the library initially. With my 4 books, I have n plus 4 books in the library. Now, can you see, children? This expression has an algebraic symbol which is n, and it also has a mathematical operation, that is plus, and also it has a number 4. This is an algebraic expression. Okay, let's move to another example. In this bus, there are some kids. 2 kids got on. Now, I want to find the total number of kids in the bus after these 2 kids got on. Number of kids in the bus is an unknown. Therefore, I used an algebraic symbol for that. Then the number of kids got on is 2. What should we do to find the number of kids in the bus now? There were p kids in the bus, 2 got on, then all together we have p plus 2 kids in the bus. Can you see this expression also have an algebraic symbol which is p, and also it has a mathematical operation, addition, and it has a number 2. This is also an algebraic expression. I hope you got some idea of algebraic expressions. Shall we move to another example? Let's see whether you can write an algebraic expression for this situation. There are some sweets in a bowl. What I did was, I took 10 sweets from the bowl and ate them. Number of sweets in the bowl is an unknown. So, I use the term p. Then the number of sweets I ate is 10. Now, can you write an algebraic expression for the number of sweets in the bowl now? Number of sweets in the bowl was p. I took 10 sweets. Then the number of sweets remaining in the bowl now is p minus 10. Now, this is an algebraic expression. Let's move to another example. I have 6 apples with me. I give some apples to my sister. Now, I want to construct an algebraic expression for the remaining number of apples I have. The number of apples I had is 6. Number of apples I gave to my sister is an unknown, so I used an algebraic symbol for that. Then what shall we do to find the number of apples I have now? There were 6 apples. I gave x apples to my sister. Then the apples remaining with me is 6 minus x. Let's move to another example. I have 9,000 rupees with me. My sister gave some money to me. Now I want to write an algebraic expression for the total amount of money I have now. The amount of money I had was 9,000 rupees. Amount my sister gave is G. Then the total amount I have now is 9,000 plus G. Now this is an algebraic expression. It has a number, mathematical operation and also an algebraic symbol. I hope you got the idea of building algebraic expressions. Shall we move to another activity? Here you can see a table. In this table, we have the first term, mathematical operation to be used, and also the second term. What you have to do is build up an algebraic expression. Here, I am going to do the first one as an example. Then you try to do the rest before I write the answer. Then we can compare the answers. Okay, shall we start? Let's go to my first example. My first term is x. Then the mathematical operation I have to use is plus. And the second term is 70. What is the algebraic expression that we can build? I can build x plus 17. Shall we move to the next example? I hope you have done it. My first term here is 5. Then the mathematical operation I have to use is subtract. Second term is t. Then I can write the first term, which is the number 5. Then the mathematical operation, which is subtraction, and then the algebraic symbol t. What is the algebraic expression I get? I get 5 minus t. Let's move to the third example. My first term is h. What is my mathematical operation? It is subtraction. Then the second term, my second term is a number 10. Then shall we write an algebraic expression using this? My first term is h. Then the mathematical operation is subtraction and the number is 10. I get h minus 10. Next example. It is little bit different. Let's see. Here, can you see the algebraic expression is given and the mathematical operation is given as plus. Second term, it is f. What you have to find is the first term. According to this algebraic expression, our first term is 15. Then I can write first term as 15. Let's continue this table. Here also algebraic expression is given. Mathematical operation used is plus. Second term also given as 42. You have to write the first term. According to this algebraic expression, what is our first term? It is r. Then I can write the first term as r. Let's move to the next algebraic expression. I hope you have done it. Let's see. First term is g. Mathematical operation used is subtraction. We have to find the second term according to this algebraic expression. Then what is our second term here? It is 1. Let's move to the next example. My algebraic expression given here is 2 minus k. Mathematical operation used is subtraction and second term is k. What is my first term? It is 2. I can write first term as 2. Shall we move to the next example? My first term here is 17 and the mathematical operation used is plus. Now what is my algebraic expression? My algebraic expression is 17 plus L. I have to write the second term. This is my second term. It is L. So I can write second term like this. My last example. I have the first term as y and the mathematical operation used is subtract. Second term, it is 12. Then what is the algebraic expression I can build? I have y as the first term, then the subtraction, my second term is 12. Okay children, now did you compare your answers with my one? I hope all of you got the correct answers. Well done kids. Now shall we move to another exercise? Here I am giving you some sentence question. See whether you can answer these questions. I'll read the question first. Varuna is X years old. His brother is 4 years older than him. How old is his brother? Now children, can you see Varuna's age is given as an algebraic symbol. Then what can you say about his brother's age? Yes, his brother's age should be an algebraic expression. Then how do we build up an algebraic expression using this information? Let's see. Varuna's age is X years old. As his brother is 4 years older than him, we can add 4 years. Then we get his brother's age as X plus 4 years. Let's move to another sentence question. Price of a pen is T rupees. Pavit gave 20 rupees to buy a pen. How much did he get as the balance? Now, can you see the price of a pen is given as T rupees. It is an algebraic symbol. Then what can you say about the balance? The balance should be an algebraic expression. Then what should we do to get the balance? We have to subtract. Pavit gave 20 rupees to buy a pen cost T. So the balance is 20 minus T. Shall we move to another sentence question? I had some money in my hand. My mother gave me 1,000 rupees. How much money I have in my hand now? Can you see the amount of money is not given here? Then we have to use an algebraic symbol for that. I can write money I had as R. I used R. Then how do I find the money I have in my hand after my mom gives me 1,000 rupees? Initially I had R rupees, then my mother gives me 1,000 rupees. Total I have R plus 1,000 rupees. Let's move to another example. Aparna brought some mangoes. She ate 3 of it. How many mangoes are left? Do you know the number of mangoes bought by Aparna? No. Then that is unknown. We have to use an algebraic symbol for that. Therefore, I can write mangoes bought as M. I used M. You can use any algebraic symbol you like. Then how many mangoes are left after she ate 3? There were M mangoes. She ate 3. Then the remaining number of mangoes are M minus 3. Okay, now my dear children, I know you got the idea of building algebraic expression, and I am confident that you can build any algebraic expression for a given situation. Okay, let's learn something new. Now my dear children, as we are stepping into the world of algebra, we should learn about algebra tiles too. Algebra tiles are squares and rectangles of different colors. Each color, square or rectangle represent different symbols. This green rectangle represents a variable or an unknown term. In other words, this represents an algebraic symbol. This blue color square represents +1 or add 1. If you want to represent +2, you have to use 2 blue squares. If you want to represent +3, you have to use 3 blue squares. Did you get it? Okay. Then we have red squares also. This red square represents subtract 1 or -1. If you want to represent subtract 2, you have to use 2 red squares. And if you want to represent subtract 3, you have to use 3 red squares like this. Now I hope you got the idea of algebra tiles. We use algebra tiles to model algebraic expression. Now shall we model some algebraic expressions using algebra tiles? Let's see. Here I gave you the key, that means what we have learned about algebra tiles. Now I want to represent x plus 3 using algebra tiles. How do I represent that? First, I have to represent x. What should I use to represent x? It should be a green rectangle. Then I need to represent +3. How do I represent +3? I have to use 3 blue squares. 1, 2, 3 blue squares. Now this is how we model x plus 3. Let's see whether you can model my next algebraic expression. It is x plus 5. Can you do this? I want to represent x. What should I use to represent x? I can use a green rectangle to represent x. Then for +5, I can use blue squares to represent +5. How many squares should I use? I have to use 1, 2, 3, 4, 5 blue squares. I hope you got the idea of this. Let's model some more algebraic expressions using algebra tiles. Here I have x minus 3. I want to model x minus 3 using algebra tiles. What should I use to model x here? I can use a green rectangle. Then I have -3. To represent -3, I have to use red squares. How many red squares? 1, 2, 3 red squares. Now see whether you can model the next algebraic expression. Here I have x minus 6. Can you do this? I want to represent x. I can use a green rectangle for x. Then I want to represent -6. I have to use a red square for -6. How many squares I have to use? Yes, I have to use 6 red squares. 1, 2, 3, 4, 5, 6. Now you can practice modeling algebraic expressions using algebra tiles too. Where can you find algebra tiles? You can make your own algebra tiles using some cardboard, like I did. Okay, what we have done up to now? We talked about numerical expressions and also algebraic expressions. In numerical expressions, we discussed that it contains numbers and mathematical operations. Here are some examples that we built. It has numbers and mathematical operations. Then we talked about algebraic expressions. Algebraic expressions contain numbers, mathematical operations and also algebraic symbols. That algebraic expressions contains numbers, mathematical operations and also algebraic symbols. Here are some examples for algebraic expressions. G minus 1, 2 minus k and r plus 42. Now my dear children, we are going to learn about substitution. What is substitution? Substitution is assigning a numerical value to the algebraic symbol. Best thing is to discuss this with an example. Do you remember this example? There were some kids in the bus. We don't know how many kids are there in the bus. Then we used an algebraic symbol to represent the number of kids in the bus. After that, we wrote an algebraic expression for the number of kids in the bus after 2 kids got on as p plus 2. Then later, I found out that there were 10 kids in the bus. That means the value of p becomes 10. I can write it like this. P equals 10. Now what we are going to do is, we are going to substitute the value p equals 10 to the algebraic expression p plus 2. This is how we are going to do this. We know that p equals 10. So instead of p, I can replace 10. Then I can write this mathematical operation as it is. Then this number 2 also as it is. What did we get, kids? We got a numerical expression. We know that we can simplify the numerical expression further. Then we can add 10 and 2 and get the answer as 12. What does this mean? When the number of kids in the bus is 10, the number of kids in the bus after these 2 kids got on is 12. Did you get the idea of substitution? Then shall we move to another example? Do you remember this example? I have 6 apples with me and I gave some apples to my sister. Then we wrote an algebraic expression for the number of apples that I have now after giving x apples to my sister as 6 minus x. Later, my sister told me that I gave 4 apples to her. Then x becomes 4. This is how we write it. X equals 4. Now we are going to substitute x equals 4 for the algebraic expression 6 minus x. This is how we do this. I write 6 as it is. Then the mathematical operation we have is subtraction. For x, for x I can replace 4. Why? Because I know that x equals to 4. Now we get a numerical expression. We can simplify this numerical expression further. 6 subtract 4 is 2. Did you get this? Okay, let's move to another example. Do you remember this one? I had 9,000 rupees. My sister gave me some amount. I didn't know the amount that sister gave, so I used an algebraic symbol for that, which is G. Then later I found out that my sister gave me 6,000 rupees. That means G becomes 6,000. I can write it like this. G equals 6,000. Now I am going to substitute the value G equals 6,000 to the algebraic expression we built for the total amount of money I have after my sister gave me 6,000. Okay, shall we substitute? For this algebraic expression, I can write 9,000 as it is. Then I am going to write the mathematical operation plus. Instead of G, I can write 6,000. Here I got a numerical expression. Then what is my answer here? I can add 9,000 and 6,000. Then my answer is 15,000. Right, children, shall we move to another activity on substituting? Here you have the algebra spider. Can you see this algebra spider is surrounded by 6 algebraic expressions. Now what we have to do is we have to substitute x equals 9 to each of these algebraic expressions. Let's see what will happen to the algebra spider after we substitute and get the correct answers. Can you help me with this? All you have to do is Substitute the values with me. Let's start. Are you ready? I am starting from x plus 1. My algebraic expression here is x plus 1. Instead of x, I can write 9 plus 1. I replace 9 instead of x. Then I get a numerical expression. 9 plus 1. What is the answer? It is 10. Okay, we got the first answer. Let's move to the second algebraic expression. I am going to x plus 12. Instead of x, I can substitute 9. Then plus 12 can be write as it is. What did I get? I get a numerical expression. I can simplify this numerical expression further. 9 plus 12 is 21. Okay, we got the correct answer for that also. Shall we move to the next one? I am going to 11 plus x. I have 11 plus, instead of x, what should I write? I must write 9. Then I get 11 plus 9, the numerical expression. The answer for 11 plus 9 is 20. Okay, shall we move to the next algebraic expression? I want to substitute x equals 9 to x minus 2. Instead of x, I can use 9. Then I have minus 2. Then I get the numerical expression 9 minus 2. I can simplify this and get the answer as 7. Okay, we are moving to next algebraic expression, 15 minus x. Shall we substitute then? I have 15 minus, instead of x, I am substituting 9. 15 minus 9 is 6. Okay, well done. Let's move to the last algebraic expression. I have 9 minus x. Shall we substitute? 9 minus, instead of x, I can use 9 because we know x equals 9. What is 9 minus 9? It is 0. Okay, well done. We got all the answers. Now let's see what will happen to this algebra spider. Wow, you have made a superhero from this algebra spider. Okay children, I hope you enjoyed substituting values to algebraic expressions. What we have done up to now, in a nutshell, we learned about algebraic expressions. Algebraic expressions contain numbers, mathematical operations and algebraic symbols. Here are some examples for algebraic expressions. Then we learned about substitution. Substitution means assigning a value a numerical value, assigning a numerical value to the algebraic symbol. This is an example for substitution. Instead of p, we substitute 5 and obtain a numerical expression 5 plus 2 and got the answer as 7. Then we learned about algebra tiles too. We learned that we represent algebraic symbol using green rectangle. Then we learned that we represent -1 or subtract 1 using red square. And also we learned that we represent +1 or add 1 using blue square. Okay, my dear children, I hope you enjoyed and learned about algebraic expressions. You can watch this lesson again from Channel NIE YouTube channel. Until we meet from another lesson, have a nice day, take care, stay safe.